Hello, scholar. Let's calculus. This journal is dedicated to my father, who was a physicist. It's written for students and non-science majors, and the purpose is to provide the students with an alternative way of consuming math. Warning: academic freedom at work. Beware. Any episode may include, but is not guaranteed to have, politically incorrect jokes, alcoholically explicit content, and offensive illustrations. Or what can you do? The First Amendment. So, suck it up. Disclaimer: no math professors were physically harmed when preparing this series. Sorry if you hoped otherwise. The good news is calculus is easier than algebra. The bad news: you have to master some algebra skills flawlessly. For example, you have to know how to factor a quadratic trinomial, solve an inequality, rewrite a radical as a power function with a rational exponent, and know what's the deal with negative exponents. Episode 3: Finding the domain of a function. Well, this is still algebra, but we really need it badly for calculus. The domain of a function is the set of all allowed values of x such that you can compute the corresponding y coordinate. For example, you can't compute f of 2 if your f is square root of x minus 3. You don't believe me? Let's try. So it's going to be square root of 2 minus 3, which is square root of negative 1, which is, Therefore, x is equal to 2 is not a good value for this function. So it's not in the domain for this function. As you are the director of the zoo of functions, you have to feed them. You feed them real numbers and then transform them in function values of these numbers. Here is a picture. Some functions can be fed any numbers, but that x to 7/2 chick is going to be dead if it gobbles a negative number. You know why? Again, we deal with the square root of a negative number. Usually, domain is expressed in interval notation. For example, all x would be denoted as in parentheses from minus infinity to infinity. Bracket is used when point is included. For example, here including 4 and to the infinity, and parentheses when the point is excluded. So, for example, here excluding 4 but taking everything above it and up to infinity. Never use bracket with infinity. This is both an error and a bad manner. Yuck. When determining the domain or safe values of x, you have to be beware of the following. Domain dangers. Here is a picture. So if you have a denominator, potentially that could be a danger because the denominator must be non-equal to 0. If you have a radical and the base is even, if it's odd, we don't care. But if the base is even, this expression got to be non-negative. And if you have a log, then the expression under the log must be strictly greater than 0. So let me say a few words on this. So the denominator must be non-zero. You probably don't have to have any extra convincing to do, but let me show you. If you feed this rational function a number 5, what happens? It sends the reaction of the function will be to go to infinity. So the function is gonna bite you in your behind and take you to the infinity with you. So that's a dangerous thing to do. As a zoo director, you should know not to do that. Domain danger 2, radicals with even bases. Well, You already know what it is. So we can compute square root of -7, but actually, if we studied imaginary numbers, we could have computed it, but we are stuck in the real world. So neither square root of -7, nor fourth, nor sixth, nor any even base of this radical, as far as you are concerned, it does not exist. When it comes to odd base, there is no problem. A good way to denote even numbers would be using formulas 2n, where n is natural number. Then you 2n, when you are running through all values of n, your 2n runs over all even numbers. The third danger is the logs. You kind of have to brush on the logs to appreciate this explanation. So the expression under the log must be positive and non-zero, because if it would have been 0, it would be equivalent to something like e to what power will be equal to 0, and it just does not exist. So what we would have here is ln 0, right? And there is no solution. Or what we would have here, in what power we have to put 2 to get -1. We would have to put it into log base 2 of -1. And 2 in no power can be a negative number. Okay, so let's look at this picture again. There are other domain dangers, but these three will cover all the functions that we consider in this course. An example of another domain danger would be, for example, arcsine of 3, right? So you can have arcsine of any number that is outside of -1 to 1 inclusive interval. But we will not have inverse trig functions in this course. For constant, linear, polynomial, and exponential functions, the domain is all x, or from -infinity to infinity, or sometimes people use plus infinity. Well, I do. And this is very nice of these functions, isn't it? And you should know what functions we are talking about, because you are the zoo director for this function. So you know what is a constant function, right? What is a linear function, what polynomial function looks like, an exponential function, right? Okay, so for rational function, remember what rational function is? It's one polynomial divided by another polynomial. So to determine domain of rational function, we have to solve the equation the denominator is equal to 0, and those will be our bad x, and then we have to kick out these values of x. Okay, for power function, first we have to rewrite it in terms of radicals and the denominators if there are any. For example, x squared is x squared, there are no denominators, but x to the -2 is going to be 1 over x squared, and you get a denominator, and so x is equal to 0 is suddenly not a good idea. Okay, so you rewrite it, then you eliminate all bad x, and let's look at the example basically. So for example, power function y is equal to x to -3/4 unfolds, so will be rewritten as, because we have a minus, we spent it to jump the floor. So now it's 1 over x to 3/4. Now we further unfold, we open this umbrella, and 4, which is the denominator of the power, will be the base of the radical, right? And so 4th root out of x cubed. Now, If x is negative, x cubed is also negative, right? So you can have fourth root of a negative number. So x better be not negative. And another thing is that we have a denominator, so x is better to be non-zero. Okay, so we want x to be greater than 0, and therefore the domain of this function will be from 0 non-inclusive, because 0 doesn't suit us. We won't have 0 denominator. But as far as any number greater than 0 and up to infinity, we can solve, we can say what y is. Let's solve an example. Find the domain of the function f of x is equal to 45 divided by square root of x minus 5, and we have to give the answer in the interval notation. Okay, what do we see here? The denominator, that must be non-zero, so x is not equal to 5, and we have an expression under the square root. Square root is even base, so it got to be non-negative. So x minus 5 got to be greater or equal to 0. Solving this inequality, we get x is greater or equal than 5, but combining with the first condition, we have to kick out the value 5. So we would be left with x strictly greater than 5. Let's draw it on the x-axis. So I will write an open circle for 5, because 5 is not included. If it would have been included, I would have put filled circle here. And then in green, I would color all my good values. So this picture represents x is greater than 5. And sometimes it's more convenient to have this picture first and then to write to what interval notation it corresponds. So this funny sign means in. So x is in the interval from 5, not including 5, to infinity. Okay, obviously since 5 is not included, we use the parentheses. If you have problems solving finite domain exercises, you have to identify the skills that you are missing. Is it factoring? Is it solving inequality? Or is it something else? A lot of people have problems with rewriting power functions in terms of radicals. So find out what it is and then use help to fix this. There are so many good explanations that you can find on YouTube, for example, now. Unless you polish the necessary algebra skills, you can study calculus without it becoming a torture. And potentially, since you went through algebra somehow and calculus is easier, you can really enjoy it. So, got to identify your algebra flaws and definitely eliminate them. Well, I drew this picture because I'm a Jewish mother and I'm a mother of 3 and I brought up 3 kids and they had to study. So Jake is asking you, sweet Jesus, to please please help him pass the calculus final, and he promises to. We don't interfere with educational policies. Have you noticed that my mother was Jewish? Do you know how much I had to study? I hope it makes sense to you guys. The end. And then acknowledgements, of course.